Okay, we're over here on my Mac. I'm using the Mac so that I've got my cursor pointed to help illustrate what I'm doing. So we'll go into presets. Now, to create a profile, there's two ways we can do it. We can select a current profile, and we can just go down here and give it a new name. Tap the pig, and that'll create a new profile, which will be identical to the profile you had selected earlier. It'll be the same type of profile as well. So in this case, it's an advanced profile. So it'll use the advanced profile editor. If we were to select the basic profile and do the same thing, it would duplicate that, and you would be using the same editor that was used for that profile. There's 4 profile editors. There's 2 basic types, which look like this. This is a pressure profile editor, and we also have a flow profile editor. The difference between those two is in this step here, the second step. With a pressure profile, you're setting pressure goals, and with a flow profile, you're setting a flow goal. So we'll get out of there, select that, tap the garbage bin to delete it. You'll notice I haven't got many profiles here, and the reason for that is I do have a lot of profiles, but they're hidden. We've got a button here with an eye icon. If you tap that button, it'll open up all the profiles you've got on disk, and you can select or deselect those to show or hide as you like. Okay, so let's get in and make a profile for this sim basket. I'll just remove that one, I don't want it. So what we want to do is create a new profile. We want to create an advanced profile. What I'm going to do is come in here and give that profile a name straight away. Let's just call it test for sim. Okay, so that's our new profile saved, and the reason I do that is a couple of reasons. Just I don't want to save over an original profile by mistake, or if something happens, I don't want to lose my changes. So you'll regularly see that I'll tap up here to save changes as I make changes. That's just to ensure that if something happens, I don't lose those changes and have to redo them. Okay, so for this profile, we're going to just use 2 steps. So what we can do is just delete all those. Now, it won't let you delete all the steps, it'll retain one. So what we can do is tap down here in the title, and I'll backspace and give that a new name, and then press enter. That'll rename it. This profile is going to have 2 steps. We could do it in 1 step. The reason I'm doing 2 steps is because the step I want for testing is going to have a flow rate around 2 mils per second, and the empty basket holds probably somewhere around 50 mil. So 2 mils a second, it would take 25 seconds to fill the basket, which is a fair bit of time. I want to do it quicker than that, so I'm just going to create a first step to fill quickly, and then we'll move on to our step we want to use for testing. So to create the second step, we tap on the plus button, and that will duplicate the first step, so including the title. So what we're going to do is rename it, and I'm just going to call it flow because that's descriptive for me. Oops, I pressed plus, so I can just delete that one. If I had pressed enter, it wouldn't have created a new step. Okay, so the names aren't important. I'm just using names that describe what they're doing. For this, we can call them whatever you like. Okay, so I'm going to save that. Now, let's go in and set up these steps. There's a lot of things I don't need to use, but I'm going to explain them anyway, just for the sake of understanding how to profile. So the first setting is temperature. On the left here we've got our temperature goal, so we set that to our target temperature goal. On the right here we've got an option to switch between two sensor points. So there's a temperature probe above the puck, just above the shower screen, and there's also a temperature probe back inside in the mixing manifold, and we can choose between those two for which we want to measure our temperature. In most cases, or in just about all cases, it's best to use the coffee sensor, but that way you're measuring above the puck. The only cases I could think of that you would use water would be maybe if you're using the machine without a portafilter, so you're pouring straight to a V60 basket or something like that, or you're using a portafilter that's not going to be under pressure, so it's likely to have air in there, and the temperature probe is exposed to air, so something like tea maybe, or one of the pour over baskets or something like that. You might find that water would work better. For any profile that's run under pressure, coffee is probably the better place to measure. Okay, so when I make test profiles, I usually change to 80 degrees C. You can use any temperature you like. I just use 80 because the machine doesn't have to heat up as much, but it's probably irrelevant. But I'm going to select 80 for this purpose. Our second setting is our goal setting. And we have two options here. We can set this step as a pressure goal, which it is currently, or we can set it as a flow goal. To switch between those two options, you tap in the middle of these icons. So if we tap in the middle here, we'll convert that to a flow rate goal, and if we tap here, it'll be switch back to a pressure goal. With a pressure goal, we can set a limit. So and vice versa. If it's a flow goal, we can set a pressure limit. And what that means is the machine will aim to reach our flow target or our flow goal, but will not go over whatever limit we set. So if it reaches that limit, it'll retard the flow to make sure it doesn't go over that limit. And the third setting for our goal is the transition type. In this case, it's set to smooth. I want to set that to fast transition. So you have two options. You have smooth or fast, and you can tap in the middle of the toggle between. A fast transition will tell the machine to go to our goal, or try to go to our goal immediately as soon as the step starts. With a slow transition, it will transition from whatever the current condition is, the current flow rate or the current pressure if it's a pressure goal, and slowly transition the change to whatever the target setting is here. So in our case, we want it fast. Now I'll just point this out. Because we've started a new setting, a new profile, it imports the settings from whatever profile we had selected at the time when we started creating a new profile. And because this profile was a pressure goal, I had a pressure goal step, there is no setting in the profile for flow goal, and that's why this is showing blank. What you need to be aware of at the time of recording this, there is a bug, so if you tap here, it will show an error. I'll demonstrate that for you. You'll get this error here saying that it couldn't find a value for the setting, and as you can see, there is no value there. The error won't cause you any problems, just something to be aware of, and I'm sure we'll get that fixed soon. Okay, so the way to overcome that is you can tap on the plus or the minus to increment, and that'll create a value. From then you can click on here and use this other UI to make changes quicker if you like. Okay, so for our fill step, we want to aim for a maximum flow rate. The machine will pump up to 8 mils per second. So I'm going to set it at 8 mils per second. I think the maximum setting you currently use is 9, but I'll test that. Yeah, so if I increase it, it only goes to 9. We don't want any limits. We just want to fill as fast as we can. Transitions fast. Okay, down the bottom here, we've got two sections or two further settings sections. These are basically triggers to tell this step to when it's finished. So in the first, on the left side here, we've got maximum settings. So we can set a maximum time, which means this step will run up to that time. If something else hasn't made it move on, that's how long the step will run for. This setting here sets a maximum volume, so you can run this step until the machine's pumped a certain amount of water, and that will cause it to move on. And we have this setting here, we can use weight, which means this step will run until the scale shows a certain weight, and then it will move on. What you need to be aware of is that the step will move on when any one of these conditions are met. So whichever condition is met first will cause it to move on. Now over here we have some more move on settings, so we can set move on if pressure is over, or if pressure is under a certain value, or if the flow rate is over a certain value, or if the flow rate is under a certain value. In this case, that's the setting I'm going to use as my move on, but I'll come back to that in a minute. We'll just fill out these settings first. Okay, so I'm going to fill this. I know the machine will only pump about 8 mils per second, so I'm just going to set that back to 8. You can leave it at 9 if you like. We know that the basket's going to hold somewhere around, or we're estimating 50 mil. So at say 3 seconds, 3 out of 24, we would only half fill the basket. You will find some profiles might have a fill section that is 3 seconds. It's 3 seconds, and that's quite common. So just something to be aware of. At this time, if you adopted 3 seconds from another profile, you're going to have to increase that if you want to fill the basket before you move on. So even at 6 seconds, we're not going to be running long enough to fill that basket, assuming it is 50 mil space. So it'd be a couple of mils short there still. So the best thing to do is just set something that's going to be well above, so that time doesn't run out before we fill the basket. But we don't want to keep this running indefinitely, so we need some other trigger to monitor when that basket's full, and that's what we'll use this section for. I want to point out here that when we've adopted those settings, it's set this to off, okay, and this is a flow rate goal. So with this set off, that's effectively giving that value, that's setting a value of 0, and what happens is when this step starts, it's looking for these conditions, and once these conditions are met, it will move on. And because this is 0, it's going to move on straight away, because we're telling it to move on as soon as 0 mils have pumped, and because 0 mils have obviously not pumped yet, that step will skip. So be aware of that. You need to have a positive value there. We're not going to use that setting as a trigger to move on, so we just want to set a value that's going to be well above the amount of volume we're going to pump before we move on. Now, I've set this at 100, and my theory behind that is that it's going to take, say, 50 mils to fill that basket. Now, my calibration could be out. It could be out by double. So the machine might actually think it's pumped 100 mil to pump 50 mil. So I'm going to set 100 mil so that I'm above that. I could set it at 200 mil if I like. The only reason I would not set it at maximum setting would be if I want to prevent a situation where no other trigger takes place and the machine just keeps pumping, and particularly if I was going to leave it unattended and do something else. But otherwise, you can set that to a litre if you like, it wouldn't make any difference. Okay, so this setting here is, as I explained, it monitors the scale. Of course, you'll need a Bluetooth scale connector. It'll monitor the scale weight, and you can move on at a certain weight. And where we use that most commonly is for moving on when we do infusion or blooming, if you prefer. So when we fill the basket, we might want to wait till the coffee puck is fully saturated before we move on to the extraction stage. And one way to tell if when the puck is fully saturated is to monitor when the first drops hit into the cup. So we can set that at 1 gram. We can actually set it at 0.1 gram. I often use 0.2 gram because that allows for a couple drops to hit the cup, and it's 0.2 grams is enough that you don't get interference from a little bit of scale drift or wind blowing on the scale or something like that. It might make the scale twitch a bit, and it's low enough that it'll sense the first couple of drops coming in. So I use that often to move on to my next step. In this case, we don't need that, so we'll turn it off. So for this step, I'm going to move on when the machine senses some pressure. So when we start, there is no pressure, and we fill the basket, but once that space is filled, it will start building up pressure. So if we monitor for some pressure increase, we know the basket's full, and then we can move on to the next step. Just to be aware, some machines, when the machine is pumping at fast flow, like 8 mils per second, some machines can show some low pressure, up to 1 bar, some slightly higher, some like 0.9 bar, something like that. So due to that, it's best to set this at least 2 bar. I'm going to set it at 4 bar. And the reason I'm going for 4 bar is I generally set this, when I'm using this setting, I generally set it so that the move on is at half the pressure rate that I expect the next step to be. So if the next step was a pressure step and I was trying to maintain 8 bar, I would move on at 4 bar. If the next step was only going to hold 2 bar, I'd probably still move on at 2 bar, just to avoid other people using the profile whose machine might register a 1 bar pressure or something like that. So I'm going to set this at 4 bar, and the reason being is I know with the sim basket, when I'm pumping 2 mils per second flow rate into it, it'll have enough resistance to the basket, will produce around 8 bar of pressure. So I'm just going to set that at 4 bar, but it's not critical. You can set it at 6 bar, 5 bar, 3 bar, whatever you want. Okay, so we've now finished setting up that step. I'm going to save those changes. So what's going to happen now is we'll just run through that. Machine's going to heat 80 degrees Celsius. It's going to pump water at 8 mils per second until it builds up pressure. And once it starts approaching 4 bar in pressure, it will move on to the next step. So now our basket's full. We want to go to step 2 and set up our conditions that we want to measure from. So I'm going to set this at 80 degrees just to keep it the same. We'll leave the sensor as coffee. This is set as a pressure goal. For this test, I want to use a flow goal. I want a constant flow rate. So I'm going to change that. And I'm going to set that at 2 mils per second. I don't want any pressure limit, and I need to have a fast transition because I want to pump 2 mils per second straight away and just have a constant curve. I don't want a transition from a lower or higher curve. Okay, so we go down here now. In this case, I'm going to set this to maximum. The maximum setting you can have for a step is 127 seconds, which is 2 minutes 7 seconds. If for some reason you need to run that step longer, the way to do that would be just to duplicate it. So if you go plus, you duplicate, now you run the exact same step for 127 seconds, and then again for 127 seconds, or until something causes it to move on. In this case, 127 seconds will be ample time for this step to run. Again, we need a positive value for the volume. In this case, I'm going to set it to max. I know we're not going to pump more than 200 mils, and if we are, there's something wrong, so I'm going to go again. And if I set it at 200 mils, it means if something happens, I had to, I don't know, I collapse, or the phone rings, or get distracted or whatever, I know the profile's not going to pump out a litre of water and overflow onto the bench or ground or whatever. So if I set 200 mils, it just works as a prevention for that if something goes wrong. So I'll set that at 200 as well. Okay, we don't need any setting there, so I've turned that off, and we don't want to move on. I'm going to stop this step manually, so I'm going to monitor the graph, and when I have plotted a curve that has a constant pressure plus constant flow, and looks pretty stable, I'm just going to end it then. And at this stage I don't know how long it's going to take for that to happen, but so I'll just leave it as a manual stop. So we've now finished that step. We don't want any other move on conditions. What we need to check though is this limits page. So on this limits page we have some stop at weight, stop at volume settings, and we have a couple other settings. So if I go back here, and I explained before, we have this limit setting here. So in this case, the machine will pump 8 mils per second, and there's no pressure limit. But if I had a pressure limit here of say 2 bar, the machine will pump 8 mils per second, but once the pressure got to 2 bar, we reduce the flow to make sure we don't go over 2 bar. In the limits tab here, I'll just set that back. In the limits tab here, we can set a limit range, which means the machine will go, will hold that limit within a certain range, basically. By default, I set all my profiles to have ranges of 0.2 for both pressure and flow. I find that works best for me. I don't see any reason to use something different, so I just do that out of habit. In this case, we're not using any pressure limit or flow limit, so it's irrelevant. You can leave that, set it to whatever you like. I just set it that. It's just a habit I have. Okay, so the preheat water tank, we have that off. The only reason you would turn that on is if you're in a very cold climate where your ambient temperature might be really cold, and your machine's struggling to heat the water for the profile you're running. So what you might do then is preheat the tank water so that the machine doesn't have to heat the water to the same extent. In my case, I leave that off for all profiles. Okay, so with this profile, as I explained earlier, I don't want it stopping for any reason, so I'm going to turn stop at water and stop at weight off. But I'll just explain those to you. Those two settings with advanced profiles are independent. With a basic profile, the machine will use one or the other. With advanced profiles, both settings are relevant, and whichever setting occurs first, it will trigger that stop. Okay, stop at water also has a companion setting over here, and what this setting is it tells the stop at water to when to start counting its volume. So if we have that set at say 23 mil, we could start counting immediately as soon as the profile starts, or we could start counting after step 1 finishes or after step 2 finishes. So you can select when to start counting that, and generally you would start counting once the extraction starts. So if you've got blooming steps or infusion steps, you would start after those steps before the extraction. In our case, we're having that off. Now, I just want to explain something about stopper weight here. Stopper weight, we said stopper weight here, but also some of the skins and other app extensions and so forth have the options or have user interfaces that can adjust stopper weight. They adjust this setting. And we use stopper weight as our final weight, or the setting we use for our final extraction weight. It's important that you don't set a weight setting here for the final step. And the reason for that is because we use this universally around the app, people will change this according to their dose. So if you want to make say a 1 to 2 shot and you're using 15 grams, you would set this to 30 grams. And then if you use the same profile for an 80 gram shot, you would set it to 36 gram. So people adjust this around the place. Now, if you create a profile and your final step has a weight setting here, say 18 grams, once the scale reaches 18 grams, this step is going to move on and the profile is going to end. So somebody will go use the profile, they'll change the stopper weight expecting it to change when that profile ends, but this setting here can conflict with that and it won't work as they expect it to. So please, when you profile, always set that off for your final step. Okay, so I've gone through, we've set those limits to off. We can save that. We go back, we've finished profiling this now. We can go ahead and run that, and we'll switch to the machine and run that now. Actually, just before I do that, there's another setting here which is not so obvious. So here we've got espresso step. If we tap on that, we open this setting here. And we can set this profile with a particular beverage type. The default is an espresso profile. We could set it as a one of these other coffee types or beverage types. We can also set it as a calibration profile or a cleaning profile. In this case, I'm going to set it as a calibration profile because that's what we're doing. But more importantly, the reason I'm doing that is, in my case, is because I'm using DSX2. And I'll explain that in a second. Another case why you would do that is if you're using a visualizer, which a lot of people do. Profiles that have profiles with beverage type, either cleaning or calibration, won't get uploaded to visualizer by the automatic uploading feature. So that might be one reason you do it. In my case, I use DSX2. Now, I'll just go back out here and explain that to you. In DSX2, this graph, the home graph, will always show the last shot. And if you tap on that graph, you can show the shot before that, the one before that, one before that, and the one before that. So we keep a cache of the previous shots, or the last 5 shots. The way I use that personally is I use this information to check if I need to adjust my grinder before I pull the next shot. For instance, as the beans age, I need to adjust my grinder slightly finer. So I'll look at this graph and I'll go, okay, well that peaked at 6 bar. I should go a little bit finer for tomorrow's shot. That's if I want something around the 8 bar mark. Here's a shot where the pressure went up to 10 bar, and so the shot before that I've gone a bit finer, but I've gone a bit finer than I really wanted to. So although that shot was perfectly okay and was drinkable, for the next shot I set the grinder a little bit coarser, so I get back down around that 8 bar mark, which is this shot here. So I'm doing that on a daily basis or every couple of days. to do that. And because I run a lot of test shots as well, testing things for people or whatever, I don't want those graphs being saved to these spots, because then I don't have these to look how I'm going with my actual coffee profiles. So if I set that profile type to cleaning or calibration, DSX2 won't save those graphs to this feature. Okay, so we'll go back to the profile. Now we have everything set. It's all saved. I'll just quickly go through and make sure, yeah, that's okay. So we're ready to run that. Now we could have made the profile a deflow profile. So the way I would have done that was select the deflow profile, then click on the profile editor. I would have changed this to 2mm to do the same thing, and say 12 bar. I want this off. Okay, I don't want any infusion, so let's set it 1 second, that's fine. Just move on pressure. We'll set it to 8 bar, because with deflow it'll actually move on from the fill. Deflow always fills at maximum pace, but by setting this at 8 bar, it'll move on from fill at 4 bar, and it would move on to this. But because this is only 1 second, it's only going to last 1 second before it moves on to that. So it effectively work the same as an advanced profile we just created. And we're just going to set the temperature for first and second half to be the same. So now this profile will run same as the advanced profile we created. Okay, I don't need to save that. It was just a demonstration how to set that up. We could have set up a basic profile. So if I go to John's 82nd profile, it's a pressure profile. In this case, it's probably not suitable. We really need that to be a flow profile to be similar to what we've created. However, you could use a pressure profile, having the insight that we know that that basket's going to be, at 8 bar, it's going to be pouring somewhere around 2 ml per second. We could set this to, here to 8 bar. We can run that for as long as we like, and we can turn any decline off, turn stopper weight off, and we have our limit off. So now we're going to fill, we just want that long enough again, so I've set that at whatever, we'll set it max. We're going to fill at maximum fill rate, 8 mils per second, until we reach 2 bar or 4 bar, let's say. Make it the same. So now this step's going to fill until it reaches 4 bar. If it doesn't reach 4 bar, it's going to run 60 seconds. There's a fair bit of water, so I will set that just for safety's sake down to 30 seconds. Or even 20 seconds. 20 seconds will be plenty of time. Okay, so now we've set up a basic flow profile to do exactly the same as what our advanced profile would do. We don't want to save because we would overwrite John's profile, so all we do here is go to Sim Basic Pressure and create a new profile like that. The way we would do it with a flow profile would be like this. We set this exactly the same, and I've adopted that from the previous profile. So we set the time maximum here, we set our flow rate, 2 mils per second, everything else is off. So that profile is now created. We will go back here and name it. So we'll name that Sim Basic Flow. Okay, so we now created 3 profiles we can use. Okay, so we're going to fit our sim basket. This is Decent's 0.3 mil sim basket. And what it is just a basket with a single 0.3 millimeter hole that gives resistance that simulates a coffee puck. The resistance it creates is at 2 mils per second. You'll get about 8 bar of pressure, which is pretty typical of an espresso extraction. So we'll fit that. I'm going to use my milk jug to catch the water and for weighing. So we'll go in and run that profile. It's probably a good idea to make sure your group head is clean, because it's a very small hole. If you've got some coffee grinds around your gasket or on your shower screen, will block that hole pretty quick. So it's a good idea to clean that before you start. My preheat check is a little bit longer because I set my machine to a low idle temperature. And I use a slow flow rate to check. Okay, you can see here step 1 is running. It's pumping 8 mils per second, it's filling that basket up. Pressure's moved up there at 10 seconds and it's moved on to our constant flow rate. So now what we're looking for is just for that pressure curve to level out, become steady, which it has now. So that's good enough for me to stop. Okay, so we now have a curve that we can use for our calibration. And I might go over Mac again so I can use the cursor to demonstrate what I'm doing. Okay, so now that we've pulled our test shot, I'll explain how to use the graphical flow calibrator. There's a couple of ways to load that. If you're using DSX2, you can go to DSX2's settings page, and there's a button here called Flow Rate Calibrator. You click that, and they'll take you to the graphical flow calibrator. For skins that don't have a direct button, you can come in here and go to the presets button, and there's a GFC button over here, so you can tap that, and it'll take you to the graphical flow calibrator. There is another way to get in there, so you go through here, it's a bit longer. Scroll down, find the thing, and use the settings button there. So probably the easiest way, you just go to presets, select this button. Now that's going to load the graph from the last shot you pulled, which is in our case our test graph using the sim basket, and we're going to use that for calibrating. You can select a different graph by using these arrow keys here. So over on the right we've got our control panel. You've got left and right keys here. We can go back to previous shots, or we can go forward again. We're going to use this test one, of course. The other buttons we have here are up and down buttons, and they'll shift the flow curve up and down, and that's what we use to visually determine a good value for calibrating. We've got 2 buttons up here. We've got this one here under default and this one under profile, so tapping those will update the respective settings. The default setting is what the app will use all the time, unless you've set a profile specific calibration setting. I'll explain a little bit more about why you would do that later. Okay, so you can see here the name of the profile we've got loaded. So I've changed it. That was the profile for the coffee. I've got the sim flow rate test flow profile loaded. Now when I load that, it's going to load whatever calibration the machine had when that shot was pulled. It's going to load that value here. So say for instance I've changed my app value and then I'm using the shot from history. You can see that's loaded whatever the value was that was saved at the time we did that shot. Okay, so I'll now set that, and that's now set that value to default. If I wanted, the way I would determine my value is by using these arrow keys here, and I'd find a value where my blue curve, my blue line overlaps my weight line, which is a brown line, and that indicates you've got the same reading going in as you have coming out. But what's important to note is you want to calibrate while your pressure curve is flat. I've got a slight inclining curve here. If I go back to, say, this curve, you can see here this is done with the same calibration value. However, my brown curve is higher than my blue curve, which means I've got more water coming out than it's going in. And the reason for that is the way we increase pressure is by forcing more water into the space, and the way we decrease it is by having less water in that space. So it makes sense that while pressure is declining, it means there's more coming out than is going in, and vice versa. If it was inclining, there'd be more water going in than is coming out. So to do the best calibration, you would want a flat curve, where a flat pressure curve where the same amount of water is going in that's coming out. And that's the advantage of using the sim basket, that you haven't got a puck that's degrading, changing resistance. You've got a constant resistance, so therefore with a constant flow, you should get a constant pressure. In this case, my test proved a slight incline. You could do 15 tests and you could get slightly different values. You might have a slightly lower pressure, slightly higher pressure, slightly more wobbly. It can vary slightly as components heat and change temperature, things like that. And for that reason, you don't really need a dead set accurate calibration either. You want something in the ballpark. Closer is obviously better, and you want to calibrate around where it's going to be most critical for your profile. So for extraction of a espresso type profile, the extraction phase, or the second phase, is where it's most critical. So for instance, if we're extracting the coffee at 2 mils per second, or that was our goal, but the water is actually flowing through at 1 mil per second, the results are going to be quite different. And similar, if the water was flowing much faster, the results taste is going to be much different. So therefore, that's where the most critical part to calibrate. Earlier on in this profile, our fill rate doesn't matter. We want to fill as fast as we can. The fill rate does matter, but our goal was to fill as fast as we can. So we could just set that value as high as we can, and it doesn't really matter. The machine's going to do what it's going to do. The other stages would be infusion stages, and generally they're pressure control stages. So the flow calibration for the flow doesn't really matter. Flow's only turned off and on to maintain the pressure or let the pressure decline, or whatever the situation may be. So therefore, this is the most important area to calibrate. So that's what we do. The other area you might want to calibrate, though, is, say, if you're using a profile that's a pour-over profile, and you might not have a portafilter filtered or fitted. You might have like an open, or you might have one of those filter baskets. In those cases, you pump water with zero pressure. So you might have calibrated at 2 mils per second at 8 bar, but at 2 mils per second with no pressure, that flow rate might be higher than the calibration. So you might find a new figure for that case. You might load a graph from one of those particular shots and set a new value and then save that per profile. So that way, when you load that profile, you'll change the calibration for the critical flow rates for that profile. So in the case of a pour over, you might not use weight. You might want to use volume, and you might want to pump, say, 30 mils per time of weight, and then pump 30 mils. And in that case, you want your flow rate to be accurate so that your volume's accurate, because if your flow rate's out, your volume's going to be a long way out as well. Okay, so that explains how to use this control panel for the graphical flow calibrator. Once you've set your custom value, or set your default value, and your custom values, you're right to go. We do have another button here. I'll just explain that. We've got a reset button. So As I was explaining, you can have custom values per profile. What the reset button does is resets them all. So it will remove any custom values you have for profiles, and the advantage of that is over time you might forget which profiles you've set custom values for, and you just want to wipe them all out. Otherwise you'd have to go through your full list of profiles here and click on each one and check here whether there's a custom value set for it. You can see here all these profiles are showing default here, which means there's no custom value set for those profiles. And it also shows you what the default value is. This one down here I saved. I thought I did, I didn't. I thought I saved the custom value. Okay, so now when I click on a profile that's got a custom value, you can see default indication's gone, and it shows what value we have saved for that profile. You could go and clear it from that other page, from the GFC page, or you could just set the setting back here till it indicates default. Click here to open the cancel or save buttons, and we save that, and you can see here now it's saved. And similar, we could set a custom value here for the profile if we wanted to. If you have a value that you know is going to work for that, or you just want to change it on the fly, you can do that. Okay, so I've cleared all those. Okay, so that's how the GFC works. Other things you might want to know is that if you ever change the pressure calibration, which you would go into the calibration page here, and you can set a pressure calibration, I highly suggest you don't go changing this figure unless you know what you're doing, and I'm happy to explain what to do. You'll need a portafilter with a pressure gauge attached to it to be able to use this feature, and the way you use it is you'd set a profile for 6 bar, and you would run that profile and record what reading you're getting, and then put that reading in there. Don't go putting the wrong reading in there, you'll mess up your calibration, and it can be a big hassle to get it back correctly. So from factory you shouldn't have to change that, but I have calibrated mine twice, and I've had my machine for 6 years, so it can get a little bit of drift. If you change your pressure, you need to change your flow calibration. You're going to get a different flow calibration factor if you change whatever your pressure calibration is. So just something to be aware on there. Ideally, if you do have a pressure meter, do your pressure first and then do your flow calibration. Okay, so our machine is now all set up, ready to go, and we can go make our coffee, and our profiles will run as we expect them.